Alright, in this video we're going to talk about the trigonometric functions of angles. Now, I've already done other videos where I talked about trigonometric functions and two different definitions of the trig functions. One definition was in terms of the unit circle and the x and y coordinates of the terminal point on the circle. The other definition of the trig functions was in terms of the ratios of the sides of a right triangle. And this definition here, this third definition of the trig functions we'll be talking about, is kind of a combination of those two. It's kind of like putting those two together, and I'll show you how all three of these definitions really fit together and make sense, right? They all, they all mean the same thing, just looked at in different contexts, basically. All right, so for these definitions of the trig functions, we are dealing with, once again, a right triangle. But the angle that we're talking about, theta, we're going to draw that right triangle so that that angle theta is in standard position. Right? If you recall, standard position means that the vertex of the angle is at the origin and the initial side of the angle is on the positive x-axis. Right? So if I have my angle theta in standard position and then I have a point P on the terminal side of that angle. Right? So the initial side is along the x-axis. When I rotate it, the terminal side would be up here, and we have a point somewhere on that terminal side of that angle. All right. Well, then, if I connect, from that point down to the x-axis and make a right triangle, I have a right triangle. So this r here, right, the r, which is the length of the hypotenuse of that right triangle, I can use the Pythagorean theorem to kind of relate these three sides. Right. Since it's a right triangle, x squared plus y squared is going to equal r squared. And then if I take the square root of both sides, I get that r is equal to the square root of x squared plus y squared. Right? And the x and the y, right, the x is the length of this side of the right triangle, which is traveling along the x-axis. So that gives me the x coordinate of this point up here. And then the y, right, this side of the right triangle is going, parallel to the y-axis here. So the side of that right triangle gives me the y coordinate of that point that's on the terminal side. Right? So I can use these definitions of the trigonometric functions when I have, just a point, out there somewhere in the coordinate plane. I want to know, like, what's the angle that takes me to that point. That's where I can use these definitions, right? I can draw that point. I can make a triangle with that point there, and whatever the x coordinate of that point is this side of the triangle. Whatever the y coordinate is that side of the triangle. And then the hypotenuse side, I use the Pythagorean theorem to figure out that hypotenuse side. The formula for that is r equals the square root of x squared plus y squared. But if you remember the Pythagorean theorem and how to use it for right triangles, you don't have to memorize that formula. If I know that x is 5 and y is 2, I just do 5 squared plus 2 squared, add those together. That equals r squared. So I take the square root, and then I get my value for r. Right, so that's how we can take any point in the coordinate plane and turn it into a right triangle. And then, once I know the three sides of that right triangle, I can use these definitions down here of the 6 trig functions to evaluate the trig functions for that particular angle. All right, so the definition for the sine of theta is equal to y over r. Now, these definitions go directly with the definitions for the trig functions in terms of the ratios of the sides, the SOH-CAH-TOA, the opposite, the adjacent, the hypotenuse. Right? So if my angle theta here is in the standard position, the y side is the opposite side. Right? The x side is going to be the adjacent side, and like we mentioned, the r side is going to be the hypotenuse. Right, so those are the three sides using those SOH-CAH-TOA terminology that if you haven't seen the videos that I did on those definitions of the trig functions and SOH-CAH-TOA and what that means, definitely check those out because these definitions here come directly from that. Right, so if you remember, sine of theta, if I just write up here my SOH-CAH-TOA, just to remind us, right, sine is the opposite side over the hypotenuse. Well, when my angle is written this way, and I put that triangle so the angle is in standard position, the opposite side is y, and the hypotenuse is r, so sine of theta equals y over r. Right? It's just the opposite of the hypotenuse. It's just now I'm labeling those sides differently because I have this triangle specifically, in the coordinate plane, and that angle's in standard position. Right, cosine of theta, well, cosine is the adjacent over the hypotenuse, right? That's what that CA means there. C for cosine, A adjacent, H is hypotenuse. So my adjacent side is x, over my hypotenuse is r. Cosine of theta equals x over r. Right, and then tangent of theta, that's the TOA, tangent, is the opposite over the adjacent. Right, the opposite is y, the adjacent is x. Tangent of theta equals y over x. All right, so those are our definitions of those three major trig functions in terms of the sides of the right triangle when our angle is in standard position. Right, remember, we use the SOH-CAH-TOA definition when we have a right triangle. That's not necessarily in standard position. The right triangle could be anywhere, or not even on a coordinate plane, just a picture of a right triangle. In that case, we don't use these definitions. We use the SOH-CAH-TOA, and we just label our sides opposite, adjacent, hypotenuse, and we go from there. But if we have that triangle, or if we have a point, really where these definitions come from, and when you use these definitions, is when you're given a point, like, take the point 5, 3. Right? What's the angle formed between the x-axis and the line that goes through the point 5, 3? All right, well, I put the point 5, 3 here, I draw that line, and that creates a triangle that looks like this, and the 5 is my x-coordinate, and the 3 is my y-coordinate, and then I can use this formula to get the r, and then I can use these definitions, what's the sine of that angle, what's the tangent of that angle, and so on. So then I can use these definitions to work with that. Whereas if I'm just given a right triangle without the coordinate plane, and the angle's not in standard position, I just use the SOH-CAH-TOA definitions. Right? But these definitions here derive directly from SOH-CAH-TOA, which again, if you didn't watch the video I did on that, you should, because all this should make a lot of sense if you've seen that video before. Right? And then the other three trig functions, the cosecant of theta, secant of theta, and cotangent of theta, if we recall from some of the other videos I've done, those are just reciprocals of the first three. Right? So cosecant and sine are reciprocals of each other. So if sine of theta is y over r, cosecant theta is r over y. Right? It's just taking this one and flipping it over. Right? Cosine and secant are reciprocals of each other. So if cosine theta is x over r, secant theta is r over x. Again, just taking the cosine and flipping it over, that gives you secant. And then the last one's tangent and cotangent are reciprocals. So if tangent theta is y over x, cotangent theta is x over y. Right? So, again, knowing the first three, sine, cosine, tangent, knowing those three definitions is the most important, and then remembering which one's the reciprocal of which, that gives you the other three, so you don't have to memorize all 6 of these formulas. You really only have to know the first 3 and then just flip them over to get the other 3. Right? And really, you don't have to memorize these formulas either. If you know SOH-CAH-TOA, and you can draw the triangle, and you remember this side is x, and that side is y, and that side is r, well then these 3 definitions come directly from SOH-CAH-TOA, with the opposite, the adjacent, the hypotenuse. Right? So those are these definitions of the angles for the trig functions when that angle is in standard position. Right? Remember, these only apply when we're in standard position. If I just have a regular right triangle floating in space somewhere, I just use the SOH-CAH-TOA definitions, and they work just as well. Right? Now, how does this relate to the unit circle definitions that we've talked about previously? And if you haven't seen the videos that I did on the unit circle and the definitions of the trig functions in terms of the terminal point on the unit circle, if you watch those before you look at what I'm about to do, what I'm about to do will make more sense. Right, so let me just go ahead and draw the unit circle here, so that the point I chose up here, pxy, let's just force that point to be on the unit circle. All right, so let me just draw a circle so that this line here, this r line, is a radius of my unit circle. Right, which, if that's a radius of the unit circle, that means that my radius is equal to 1. Right, because that's the definition of the unit circle. It's a circle with a radius of 1 and center at the origin. Right, so a line segment that goes from the origin out to the circle, by definition, has a length of 1 because it's the radius of the circle. All right, so if my r is equal to 1, well then sine of theta is going to be y over 1, which is just y. Right? Cosine of theta is going to be x over 1, which is just x. Tangent of theta is still y over x. Right? So if you remember the definitions we talked about from the unit circle and using the coordinates of your terminal point on the unit circle, well, sine is the y coordinate. Right? Cosine is the x coordinate. Tangent is the y over the x. And then these 3 over here are still the reciprocals of those original 3. Right? So cosecant would be 1 over y, secant would be 1 over x, cotangent is still x over y. Right? So these definitions also fit in with the unit circle definitions of the trig functions when that r value is equal to 1. Right? Because when r is equal to 1, that means that this point is on the unit circle. Right? Now, these other definitions, y over r, x over r, that's when our point is not necessarily on the unit circle, right? R doesn't have to be 1 in order to use these definitions, right? So like I was saying before, if I have the point out here, 5, 3, well, that point is not on the unit circle, right? But I can still use the definitions of the trig functions to figure out things about that angle that meets that point, right? Even when the point is not necessarily going to be on the unit circle, right? But if r is equal to 1 and that point is on the unit circle, we can see that these 2 definitions here give us the same thing. right? And I did a similar thing when we talked about the SOH-CAH-TOA definitions and showed how those also correspond with the unit circle definitions, right? So we have three different definitions of the trig functions, right? The unit circle ones, we have the right triangle ones, and then we have the right triangle in standard position, right? Those are the ones we just talked about here, right? But none of them contradict any of the other ones. They all fit together. They all kind of complement each other. You know, they're talking about the functions of these angles just in different respects, right? The unit circle definition is just, you know, I have an angle, just an angle, just any, you know, just in general an angle, and I can use the unit circle to figure out, you know, the sine, cosine, tangent of that angle. You know, the SOH-CAH-TOA is when my angle is part of a right triangle. I can use these definitions to figure out the sine, cosine, tangent of an angle, right? And then these definitions up here are when I have, you know, an angle in standard position and I know a point on that terminal side, then I can use these definitions to figure out the sine, cosine, tangent of the angle, right? So they all mean the same thing, just in different contexts, coming from, you know, different perspectives, basically. All right, so that's my explanation of these third and new definitions of the trig functions. And check out the other videos that I'm going to do on this, where I'm going to do some examples where we use these definitions to figure some stuff out, right? So make sure you check the other videos I'm doing here.